Okay, this is part 2, so there'll probably be part 3 of this whole day, okay, to make sure that you have an understanding of everything. All right, so we're going to go on and do the next one. I believe these are the steps for the TI-84, if you have one, in order to find the standard deviation. All right, so we're going to take all these numbers here, and just like we did before, we are going to put them all in our data, So we're going to clear out our list by hitting data twice and enter. And then we're going to type these in, 3 enter, 4 enter, 7 enter, 8 enter, all the way until we get 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers entered. So it should be looking for your 10th one in the bottom. All right, we're going to skip all the way down to the 4th one, and we're going to figure out our standard deviation is 4 point, and I'm going to go ahead and I'm going to round to the nearest hundredth. 4, no negative. Let me make sure. Standard deviations are not negative. So this is 4.86. All right. Then you're going to get out of your table and you're going to do 4.86 squared, and that gives you 23.62. Okay? Then you're going to go practice the next one. Plug all these numbers in. You're going to get a standard deviation of 4.81. You are going to square it, and that number goes over here, rounded correctly, of 23.14. Okay? I'm just going to keep giving you these answers. Input your next data. You're going to figure out the standard deviation is 32.22. Square it to find the variance, and it is 1038.13. And the last one, doing it again, standard deviation is 3.87, and you're going to square it, and you get 15 by the time you round correctly. Okay? Now, look at these numbers. Look how big this standard deviation. That means these numbers up here are much more spread apart. And you can tell, look, I have a 63 and I have a 135. My data is very spread apart. Whereas in this one, my standard deviation is very low or small. And look how close together all my numbers are. Okay, so this tells you, the standard deviation tells you how far apart your numbers are. All right, now we're going to go to the next part of what we learned in class. Data distribution. Okay. All right, so we're going to talk about normal probability, skewed. So this is talking about the way data values are clustered or grouped, okay, are clustered, okay, way they're clustered or grouped together. So if you notice, well, I'm going to start all the way over here. Look how perfectly symmetrical. That means if I divided this into 2 halves, this half is pretty much the same as this half. We call this a normal. Those are quotation marks, and my ink is running together. A normal distribution. Okay, oops. Oh, they didn't like me doing that. Sorry about that. A normal distribution. Okay, perfect. Not perfect, but pretty symmetrical. All right, and if you look at these other two, they're not symmetrical. So what you can tell is as you go over this high part, you get this, what we call a tail. And the tail is on the positive side. So we call this positive skewed. So I want you to make sure when we're talking about skewed, you are looking for the tail. Okay? That's going to help you determine what it's called. The tail is on the positive side, it's positively skewed. The tail is on the negative side. Okay, this is also the tail. This is negative skewed. Okay, it is not symmetrical at all. But back to the normal distribution. It is symmetrical. It looks like a bell-shaped curve. It does. Kind of looks like a bell. Okay? And it's defined by the mean and the standard deviation. So that's what makes these. The mean and the standard deviation is what makes this normal distribution. The area under the curve, all the area under the curve, is what we call probability. Okay? We're going to work on finding some of that out today. The total area under the curve is equal to 1, or if you change this to a percent, I call it 100%. Okay? So 100% is the total area under the curve, or 1. Okay? All right, so let's see what that means. So here's a picture of a bell curve. The mean is this symbol right here in the middle. Okay? That's the mean. Oops, let me see if it'll let me draw this. There we go. Maybe. Here we go. That's the mean, right in the middle. And then what we do is from the mean to the positive and to the negative is a standard deviation. Okay? So going from this, the mean, to the next dash line, this is 1 standard deviation. And then 2 standard deviations from the mean. And then 3 standard deviations from the mean. When you draw this bell curve or normal distribution, it's only 3 standard deviations from the mean going in the positive direction and going in the negative direction. Now, in these little spaces here, where we say that it's 1 standard deviation from the mean, that talks about 34.1% of all the data is within 1 standard deviation. So this is the same on both sides, because both sides is 1 standard deviation from the median. So I'm going to put it up here, 0.1%. Actually, within 1 standard deviations, back up, don't write this, because 1 standard deviations is on both sides, and if we add these two together, it is 68.2%. Of all the data falls within 1 standard deviation of the mean. Now, how much data falls within 2 standards? Now we have 2. We have 1 to the positive and 1 to the negative. These are 13.6% between 1 and 2. 13.6%. And yes, you will have to remember these numbers, but you only have to remember one side because it's the equivalent on the other side. Now, if I add all this up, 13.6 plus 34.1 plus 34.1 plus 13.6, that is within 2 standard deviations of the mean. It becomes 95.4% of all data falls within 2 standard deviations. Now, 3 standard deviations, well, 2.2% of all data is between 2 and 3. Same thing on this side. So if I want to know how much data falls between 3 standard deviations, I'm going to add all of these up, and I get 99.8% of the data falls within 3 standard deviations of the mean. Now, this little bit out here, so that means greater than 3 standard deviations, or over here it's less than 3 standard deviations, is 0.1. 0.1. And if I added everything up, it would total 100%. If I changed 100% to, take away the percent, you would divide it by 100 and you would get 1. Okay, so that's where I got the 1 from when I talk about the total area under the curve. Okay, but as long as you're dealing in percents, we're going to say 100%. All right, so let's look at an example of a problem and how we label. So we're going to label first. So the weights of 50 football players, so I know I have 50 players, are normally distributed, that's why we have a bell curve, with a mean, very important, a mean of 178 pounds. So I know my mean goes right in the middle of 178. It has a standard deviation of 8 pounds. So I need to label all of these values and I need to label all of these values. When you go in the positive direction, you are going to add. So 178 plus 8 is 186. And then I'm going to add 8 again to get 194. And then I'm going to add 8 one more time to get 202. Now, to do the numbers this side of the mean, we are going to subtract 8. So we added 8 on this side. We are subtracting 8 on this side. So 178 minus 8 is 170. 170 minus 8 is 162. And 162 minus 8 is 154. Now, we've already learned that this is 34.1, this is 34.1, 13.6, that means this is 13.6, 2.2, 2.2, 0.1, and 0.1. So now we can answer any question I give you. So let's see what we can do. It says, what percent of players weigh between 178 and 194? Okay, so I'm going to come over here and look at 178. Here's 178 and 194. So it says what percent? So I am going to add the percents between 178 and 194. So I'm going to add 34.1 plus 13.6, and I get 47.7%, because these are percents that I'm adding up. Okay? All right, not too bad. What is the probability, or percent, that a player weighs at most 170 pounds? Well, we got to remember what at most means. At most, that means they can only weigh up to. Okay, so this means less than. Remember, if I told you could only take at most 2 cookies, it means you can't take any more, but you could take less. All right, so less than looks like that. So we're saying less than 170. All right, so here's 170. So I want to take all the percents that are below or less than 170. So I have 13.6 plus 2.2 plus 0.1. And I'm going to add all those up and I get 15.9%. All right, I'm going to go on to part 3 and we're going to pick right here where we left off.